I work for Capital One in the United States. I came here to give a presentation. 2 years ago, I gave a presentation on RAM disk in Amsterdam. But we work on with Redis and different in-memory solutions. So I just want to share a little bit of knowledge and some discovery that there's been in last few months in Capital One. So we had a problem scenario that we want to have a website that very fast and frequently refreshes and provide the data very fast to end users. So that our SLA was under 200 milliseconds. We want to provide the data to end users. Not many databases provide this kind of round trip to get the data back from the database back to the UI. That's one of the scenarios. Another scenario that we want to share the different keys and authentication between databases and middle layer or backend. So it's multiple different reasons that we want to have some fast caching protocol. So we went into research on feasibility and what products are available and what we can use. And also we have an ETL pipeline that's going to load all the data and start using this data. So we start with Redis. Redis is in-memory key value store. It has persistence as well. It's open source. It's written in C. It can handle up to 2 on 32 keys, and it was tested 250 million keys. You can see in the more blogs about actual usage and performance testing, but it's one of the most popular key value stores. It's not really a transactional database like maybe Oracle, MySQL, and something else. It's just a caching layer. And it's a key value store, particularly called like that. It stands for Remote Dictionary Server. It's released in 2009. And it started as a single developer trying to improve performance of log.com website. So they had an app that was having the bad traffic or many hits to the database. They just want to improve and then to get last n items from users visiting the site. So basically, it's self-developed single guy in Italy. They developed Redis and then become very popular. It supports many different data types. Strings, lists, sets, sorted sets, hash. I'll show you a little bit in a few slides about that. Just a regular protocol, Redis key, it has a key and a value. The values can be strings, it can be lists, it can be sets, and so on. It can push and pop elements. It can fetch arbitrary elements from the key. It can provide the sorting as well. And data for the Redis, it can be asynchronously written to the disk, which means that during the write is not blocked for the next operation to come, so everything seems seamless. As it's very efficient with memory. As an empty service, when you start Redis, it's only consume 3 megabytes of RAM memory. And for example, for 1 million small keys, string value pairs contain about 85 megabytes of memory. For 1 million keys, for hash value, for example, 5 fields, it's going to use about 160 megabytes of RAM. It's very simple to start using. If you have a Linux, Mac, or Windows, you just wget from specific location, untar, cd into it, and go make. And then that's all these 4 commands. You can start running Redis. So it's very easy starting point. It has a Redis CLI. And when you say Redis CLI ping, it's going to respond with pong. That means it's alive. This is very simple. I hope you can see it's a little bit small letters. It's the latest version, Redis 5.0.5. When you start Redis server, it's going to just authenticate and show that it's running in one window. Then you can open another command line interface and just connect to it. It doesn't need to be on the same server. You can open the ports and connect from a different server. As long as you have ports open, you can communicate with the Redis server directly. This is example. at the beginning, you can say flush all, or after certain operation, it's going to delete all the keys in the database. If you want to see all the keys at once, you can just say keys and star. It's going to show all the keys. Right now, it's empty list because we just flushed it. And then you can set one of the first simple operations. You can say set some key and some value. In this case, we have foo as a key and 45 is a value. And it's just going to respond like, OK. So when you want to receive the key, you just say get and the key, and you get the value of the key. And if you say keys and star again, it's going to show how many keys you have. Right now, we have only one key. So you can see how simple you can start, but then you can add more stuff. So if you get and set, if you have sets, they are just strings. So if you have spaces in a string, you will double quote around it. And then also you can add integers. The difference between string and integer, strings you cannot manipulate too much, except you can change them. But integers you can increase. So you have increase by, and then you say the key number 2, and then for how much you want to increase, you get a new value. So you see I increase from 333, adding 5, 338. And with this command mget, I can get multiple keys, and it's going to show value for key 1 and value for key 2. So if you want to retrieve many keys at once, you can do that. Some applications they require to grab, almost like you do select 10 from the database. This is how you can do it in Redis. Deletion of keys is also very easy. You just say delete and the key name, and it's going to delete. But also you can say you want to expire some keys. So you can set a timeout. So if you want, after, in this case, 5 default by seconds. So if you say expire after 5 seconds, I'm testing every second. I still have the value of it. But then at the end, after 5 seconds, I don't have anything. So that can be important if you want to have a session expiration, if you want to have some security around your website or password expiration or anything like that. That's why it can be useful for. You can also set different values inside the keys, and also you can do multiple action at once. So if you say get and set for foo and buzz, you're gonna get bar, but then also after that, when you say get foo, then you get just a value of that. Also, another combined action is set nx. So it's going to set the value if it does not exist. So if some key exists, it's not going to do anything. But if it does exist, it's just going to set as a new key. That can be important if you don't want to change if something already exists. List operations. They're just regular linked lists. So you can push and pop on both sides if you have the list. And you can resize easily. So for example, here you can say on the left side, I want to push one key and value, and then push again for the same list. And then you can do L range. So range is going to show from the 0th. That's how it starts, from 0th element to number 2. We can see both elements here. Or if you pop from the right side, one of the elements, and then you do again the same L range, is going to show only one element. So you can operate like just a regular array. You can also do blocking pop. So the list is going to have the element until you remove them. And then here's just a representation how everything looks like. So you have one key, and you just have a head of that key, and keep adding the value until the end. So you can do also set operations. Sets are very similar to arrays, but they're unique. So you can manipulate in different ways. Arrays, you're going to have duplicates. In sets, you will not have. And you can add the keys and the values by using set add. You can check what are members of the sets. You can also intersect two sets to see what is the common value between two sets. You can union two sets, so you can have from both sets together. So that's something that can be useful. So you can start thinking that the Redis is not just a regular caching layer. It has a little bit built-in logic that you can reuse if it has specific use case. Sorted sets is very similar like sets, but you can add a score. So it's almost like you add the index in front of each key. So you can say for this sorted set, for this key, I want to add 1 and 2 and 3. And then you can do the range for that. And then you can specify how to sort it. So let's say from 3 to 1, and that's how it's going to be sorted. Or you just want a subset, or you want to do in the other direction. So it's just a little bit more functionality around the sets itself. This is just a representation, how it looks like. And then hashes. Hashes are very popular and very useful. It's almost like a mini table inside the cache. So you have one key, and then you can have multiple key and value for that one key. It's almost like a second layer of the keys with a key and value. This is example. You say hset for that one hash, and then you said key 1 is going to be value 1, and then for the same hash, I'm going to add another key, another value. So now I have two keys in the same hash. If I want to get all from this hash 1, it's going to say key 1 value 1, key 2 value 2. And I just want to list the keys for that hash 1. This is two keys. And if I want to get the value only from that hash, you can get key 1 from that hash 1 or key 2. So you can see it's very simple to access, but you can manipulate and see if you want to get the keys or values or kind of just extract the portion that you need. There is also pub and sub. That you want to subscribe to a channel. So for example, this is like a streaming in Redis. So you can publish to some channel, and this channel, let's say called Joe, and then it's going to be a test message. And then when I send a test message here and I subscribe here, then I will get the values from that. Okay. So it's basically you can have two windows open or two channels. Maybe one is listener, another is somebody who is publishing the information. As soon as you publish to the channel, the listener will receive that. So this can be useful for if you want to build, let's say, a chat application, or maybe send SMS message or something like that. It's really fast. This is just the same thing, the publish and subscribe, but you can do multiple channels in the same time. In this case, there are two channels, and you're getting the message, you can send the message, and so on. So you can start developing a little bit more complex operations for the streaming. They also support the sort keys. You can sort them. Let's say I have a couple of keys, they're not alphabetically sorted, but when I do this sort based on alphanumerical, it's going to start sorting alphabetically from first character to the last. You can do in the reverse order as well. And then you can do some maybe limits as well. So this all logic is built into Redis as well. It comes by default. You don't need to add additional modules or anything like that. And then you can do transactions. So transactions, they can be useful if you maybe operate in the banking or somewhere where you need to do several actions before you commit or before you finish. So you don't want to finish one and maybe something in the middle happen, update or something, and then you do the previous or planned action, the second action. So that's where the transactions are good to have. So you can say multi, you start with that, and then you set the key and the value, and you get, and you increase, and then you say execute. So all this will be executed as part of one transaction. So when you do exec, you can see three at once. But this can be, you can imagine, this can be hundreds of commands if you really want. So it's really important. Let's say if you have 2 banking accounts. If you want to transfer money from one banking account to another, you really want to make sure that the money is not dropped from one account before it's added to another. You want to do in the same action. Because if something happened, the money can get lost in the middle, and then it's hard to troubleshoot. So integration, just to this general pattern, what people do, and in the companies, you can have front-end data in RAM. It's denormalized from the regular transactional database, and is optimized in that way for speed. And then front-end talks to the Redis, and then Redis has the keys and scoring vectors that you can use almost like indexes. And for example, backend data can be MySQL or other. That's going to be Redis will be caching layer on top of the database, and it's going to be manageable. You're going to have a schema, and admin will talk only to the MySQL, and then you have a sync between that Redis caching layer to the database, and object relational model to manage and sync the data, and then you can have automatic indexing. So it's just one potential use for Redis. Security around Redis is designed to be secure within its own network. So you should really be careful about accessing who do you give the ports to. If you run on the cloud, you want to make sure they have security groups well defined and who and when can access that. But also there is a layer of authentication that you can set in redis.conf file. And then also you can authenticate users with username and password. So if you don't have a password, you cannot retrieve any key. This example, you setting up a new user with some password, and you can set the granular access. You want to have read-only, or what kind of functions you want to add for that user, for some other user. Maybe you want to have a different set of actions. And then admin will have all possibilities to run. So you can really specify which user have which level of access. This is one example of what we have as application. This is a stack, very simple one. We have a user that is accessing API as a web service, which talks to a microservice. This can be Node.js, Python, many different. In this case, is Python with Tornado module, which distributes the keys to the cluster of Redis servers. And then in the backend, we also have a database. Let's say this is Hadoop and Hive. And then ETL load is getting the data from Hadoop and manipulating to make sure that it's going to fit the Redis schema, and then push all the data to Redis cluster. If we zoom into that API and Redis cluster, it's 3 Redis cluster, 3 servers. API is communicating with all of them and deciding where the keys is going to go. So you can also do a mirroring of the servers. So if you have 3 servers, 3 clusters, you can add a mirror for each. So in case that this server itself get crashed or something happened to it, gets deleted, you can fail over to another server that has a replica of that first server. This is something that you can build on your own, but I'll show you later how it can be automated. Just a data loading process. We have a preparation for insert. Everything is on the fly, loading from a file. It loads each key separately in the 3-node cluster, and then it was measured performance. And this is how the distribution of keys goes. So API that I mentioned, the Python with the Tornado module, was loading by using hash algorithms for the keys and deciding where each key and value will go. So the logic in the brain is on that API server, and as soon as some new line comes of the key and the value, it decides it's going to go to Redis server 1 or 2 or 3. This example, first key goes to the first server, second the second, third, and a third, and then go back again, 4 key on the first server, and so on. And the same way, same brain is gonna find the data. So if the end users wanna hit that same API and retrieve the key and a value, it will know, for example, the key 3 is on this server, and will pull from this server, Redis. This is one way to create a cluster, which is application logic and loading and retrieving is outside of the cluster. But the Redis has its own way to also manage this. So you can think about, depending on what level of comfort, depending on what you have, you can use separated cluster and do logic outside of it, or you can use Redis built-in function for clustering. I want to mention also there is a Redis SQL. So the Redis by default is a key value store. But if you add additional modules, one of them is called Redis SQL, is independently built differently from developers from the main developing branch, but is .so module, so you can import in the Redis. So when you import it, it's basically implementation of SQLite inside the Redis. So then you can run a regular SQL commands, almost all ANSI 99 compliant commands inside the Redis. It's pretty fast, 130,000 transactions you can use. It has some limitation, I'll show you later. Or you can just go here and find more about it. It has the same, Redis SQL has a JSON support, and you can manipulate that JSON. You can access specific object and the key, and has also full text search inside. This is example, how would you run it, Redis SQL? You can create a database like you would do in regular transactional database. And then you can create a table, and you have a key and a value. And then you can set the values, and then you can insert the values, and then you say select star, like you would do in regular database. And then that's how you get the answers. The one limitation that I noticed in this particular module is everything is set by the key. So you cannot really partition into multiple, let's say, to have the cluster running of all the data. Everything that you see in this Redis SQL is going to be in one server only. So that's a little bit limitation, but other than that, it's pretty good if you want to run some regular SQL in Redis. So I would suggest you to try it. I had pretty good results. It's pretty fast, many actions, and SQL queries execute really fast. And it all is in memory. Redis has also built-in implementation Sentinel that's clustering in the Redis. You can set it up. There's just example. You can set up master and slaves, and then they will talk to each other. And then you can set for the master and for the slave some of the keys and the values. It's active-passive cluster. It has partitioning. You can split the keys into 16,000 key slots. Each cluster requires 2 TCP ports because they need to communicate between each other. All nodes, they're connected with a service channel, and then you can base port from one to another, and you can, this is binary, it's a binary protocol between 2 nodes, and is optimized for the bandwidth and speed. And you can use the regular ASCII protocol to talk to it. They don't require proxy. So this is how it's happening. Once we have 2 nodes, they start talking to each other. One is asking, is the other alive? Another is responding, is alive, and that's how they know. They're both are aware of each other, and then they start acting based on that. Besides all that I show, you can use different programming languages. This is just a Python. Let's say regular, there are several different Python modules. You can just do pip install Redis and then start using import, and you set up hostname, port, and password, and then you start using. So this is a Python command. It will execute against wherever the host is. In this case, it's localhost, but you can set up remote host or a cluster. Another example, you can set the for loops and add many. This is just, for example, for benchmarking is pretty good if you want to send millions of keys and see how fast they will record. You can use PHP as well as a programming language. Node.js, Java, C#, many languages that provide libraries for Redis. You can also use pipelining. That's when you want to send multiple commands at once, similar to transaction, but this is more related to networking. So if you want to make sure that nothing gets interrupted when you send many messages to a cluster, that's pipelining is good for. This is how you would use. You can set pipe and then key and value and start executing. So in this case, execute 2 commands. First is setting, which is true. Another is getting the value. So somebody might ask, okay, what if the server itself runs out of memory, what will happen? So there, typically, the service itself is going to be killed by a Linux kernel. But in a modern Linux system, the system will start swapping. So it will use the hard drive to store. It will slow down a little bit. But also you can set, if you worry about limitation of the memory, you can set the max limit for the memory usage. So you can say, on this server, I want to use only 1 GB of RAM. So when the Redis notice that is approaching to 1 GB, it will start either deleting the oldest one, or it will, you can configure what you want to do. So for example, usually the most oldest key is going to be deleted so to make a space for the new one. Redis is by default single-threaded. But that's usually not a big problem because it's really fast. It has hundreds of thousands of transactions per second. So usually it's a memory or network bound, not really CPU bound. So that threading is not really that important in type of Redis. From the Redis 4.0 and onwards, they start adding a little bit of threading, but just for deletion of the keys in the background. Maybe in the future they will add more, but so far I didn't notice that it's really needed. Redis also has a periodic, you can set dumps, so you can save all the data from memory into the disk, let's say in the file, so you will not lose the data from memory. By default, everything is run inside the memory. But you can say, I want to, every X seconds or every few hours or every day, I want to dump everything snapshot into the file. Or you can execute the command on the background save to save all the keys. And then later you can just load all the data. This is performance testing I did a few months ago just to see how fast is for one node, one server, Redis saving. Here you can see how many milliseconds on this y-axis. On x-axis is how many keys are being sent per second. So you can see when I send thousands of keys per 1 second at once, it will take about 500 milliseconds on average to store all those different keys. And then you can see the values. The actual size of the keys is a couple of kilobytes. So I would say usually it's pretty safe to assume that you can follow your SLA. If your SLA is under 500 milliseconds, you can add another node and start saving in order to decrease this line, if you really want. But for most operations, even one node was pretty good enough for us. In terms of hardware, if you have just a little bit faster writing system that can run and talk to the memory really fast, of course it's going to be faster than some older versions. And then some of the small lesson learned, 64-bit instances, they consume a lot of RAM. So you can use monitor as well to see what's going on. And then master-slave configuration is not perfect yet. Some manual interaction is needed. So typical use cases is, for example, stock prices. If you want to have millisecond response, that's where you're going to use for chats, bidding system like eBay. You can think of it's pretty good use case because you may have thousands of users bidding in the same time, and that 2 millisecond response is really important. That's where you want to get really fast transactions. It's good for analytics, real-time data collection. If you want a real-time chat communication, that's pretty good. And I'll show you. It's a little bit like a replacement for Memcached. I'll show you in a second. So just to go over Memcached, that's in a way similar to Redis. It has a high performance. It can be used with a lot of RAM. It's in-memory built-in solution. And also it has kind of similar approach like Redis. It's also started with somebody wanted to improve the transactions on the website. It was doing slow. It has 20 million dynamic page loads. So they want to implement in the memory solution. When they implemented Memcached, it reduced the database almost to 0 because everything was hitting the memory caching layer. Facebook is one of the biggest users of Memcached, but it's not just the regular Memcached. They added additional layers on top of it, so they enhanced it. And they have hundreds of Memcached servers. For small companies, probably this architecture that Facebook has implemented is going to be a little bit harder to maintain by a few developers. But anyway, it's possible. This is how you would start. You just download, let's say, the latest Memcache, untar, cd into it, and then configure, install, and start. It has some limitations. One of them is the key size is 250 bytes. Last recently used are cycled out. And then eviction is not so common, but it has threads, but doesn't support clustering. So, at least by default. So what Memcache is not a persistent store, and it doesn't have by default storing snapshot into the file like Redis has. It's application specific. It's made for the large object cache. It's fault tolerant, and it's not fault tolerant and highly available. Use cases, typical use cases for social networking, for some ads, gaming, e-commerce, session caching, database query scaling, a little bit similar like Redis. This is a typical architecture. Memcached is sitting in between databases and then application layer. And then it can serve as being the layer that's going to be hit by APIs. So it's good for quick optimization. Is good for maybe homepage when you want to have millions of users hitting the web page, so it's going to be very responsive. But we don't want to use Memcached when it's really large objects. By default, the value size of the Memcached is only 1 megabyte. In the newer version, you can increase it. And then the keys is only 250 characters. And then just a quick comparison. So Memcached, it can grow in memory really fast. And also, when you delete the keys from Memcached, the memory reservation, it will kind of stay stable. With Redis, they're a little bit better with managing memory. So as soon as you delete the keys, the memory usage of the server will drop down. So it's in that way a little bit better. Memcached is volatile, so if something happens, it's kind of you're on your own. If you need a high performance, there might be slight improvements Memcached compared to Redis in terms of performance, but nothing drastic, maybe 10%. But all other functionalities are much more in Redis. So, for example, Redis in disk I/O and writing, Redis is much better because it's the only one who can write to the disk. Memcache, without third-party library, they cannot write to a disk. And then read and write for both is extremely fast, and this is talking about the memory itself. So if you need something fast, both are good. But if you need something that's going to be stored on the disk and then you have snapshots, then you would use Redis. And this is just table comparison, and you can see the persistence is missing for Memcached, replication as well if you want to build the master slave, and slightly faster Memcached, but this is not significant. But memory usage by default is smaller, but also when you delete the keys, it's much better. And you can see many other functions, like different data structures, hashes, sets, ordering, that's available in Redis. In Memcached, it's not. So in general, Redis can do very similar stuff like Memcached, but it do a little more. And Redis can act as a cache. I mean, the value for the Redis, it can be 512 megabytes, maybe in the newer version even 1 gigabyte. By default, Memcached, that object size that is 1 megabyte. For this newer version 1.42, you can change with -i command to increase the default maximum size of the value. And then the Redis, by default, you can save the data to a disk, so you don't lose, but you can turn it off. So you can increase the performance, but you lose on availability of the keys. If you need some good performance, both are good. There are many different companies that use Redis. And so I would say the Redis is more powerful. I would use it in front of, instead of Memcached, has many more features and functionalities. So that's my suggestion. Redis on AWS, just a few slides here. Now it's a new version available in AWS. It supports asynchronous replication, improved read performance. So I showed you how you can start by yourself on one server or even create a cluster. And this is the automatic way. So it's all these managed services it's done for you by AWS. It's scalable. It has clustering topology. You can decide how big the cluster will be on AWS, and you can allow to grow. And you can choose different instances, different servers. And then you might heard ElastiCache. ElastiCache is a managed service. It's fully managed service for Redis. So all you need is to log in AWS console, and you set up the Redis cluster, and it will be created for you. It has a built-in software in the back end. It has automatic write, throttling, swap memory management, failover. So many features are already built in, so you don't need to do by yourself. This is how you would do. You just go on the AWS cluster, you say what is the name, what version of Redis you're using, port, and what node, how many gigabytes of RAM. And then maybe additional parameters. Do you want to have a failover? What kind of security? You can have encryption as well, and you can have automatic backups. If you want to add more nodes, let's say you started with 3, maybe you need 5, you can easily add additional nodes to the same cluster. This replicas is going to be in the same availability zone, and then you can just increase the cluster. And if one of the nodes stop responding, the ElastiCache will just change the DNS record and point to another node, and then you will not lose anything. Everything will happen behind the scene, and you will not experience any degradation because Replica saves the keys from one node to another. So if something happened with one server, it's automatically done. Everything in a background. So it's pretty good. It has a backup and restore the features. So if you want to tomorrow start another cluster in another zone or region, you can easily do with backups. And you can start the entire Redis cluster from the backup itself. You can do encryption in transit that supports, and also encryption at rest. So it's really good for if you want to secure your data. It's all on AWS. So that's all for now. You can find me on the booth, but I want to see if any questions so far here. Sure.
You said Redis.
Yeah, I saw you.
You said Redis would be good for analytics. I don't remember you explaining how.
Fragmented, you say?
You said Redis would be good for analytics.
For analytics.
Yeah.
Oh, if you want to just save the data while you're running something, you can be almost like a real-time saving. Let's say you're streaming something with Kafka, or you're doing some real-time actions. You can use Redis to kind of keep track in the same time while you're running all this data, and then you can run analytics on top of Redis based on that. So it's kind of, instead of offloading data and then running later maybe as a maybe batch job to run your analytics, you can kind of run analytics on the real time. That's what I meant. So maybe let's say how many visitors you have on your website. What are visitors doing? Are they buying something? Are they canceling orders? Are they, all those kind of analytics you can show real time with Redis because it has a backup system for it. Sure. Sure.
Thanks for the talk. I've got a question about the data distribution at Sharding.
Mm-hmm.
So when you talk, say, a class of 3 servers, you've got P1, say P4, back to server 1.
Mm-hmm.
But what if you add one more server? Would the headers be different, and how would you?
Depending how you start with, if you start like I showed at the beginning, where you manage your logic, maybe as a Python API that's going to talk to each, maybe 3 servers, that logic, it needs to be handled there in the brain. I personally didn't try adding additional server. Yeah. I would need to test if it should work by default. It might need a restart. But if you have, for example, if you use AWS as a managed service, that logic and that what you described that scenario, it's already built in. So if you add additional node, it will start redistributing keys so that it's evenly distributed later.
So the data is moved around?
Yes. Mm-hmm. Mm-hmm. Yeah.
I also have a question about sharding.
Okay.
So basically, we have to do it ourselves, or there has to be some third tool that will redistribute the data. There is no identification of additional servers. If something goes down,
Mm-hmm.
it will be just gone, right?
Yeah.
And if there is a very hot partition, it will remain hot. There is nothing out of the box that will redistribute the data to deal with any of that.
Yeah. So for that case, I would recommend starting with AWS. Because a lot of these functionalities is built in as a managed service in ElastiCache, which already have all that replication. So as I showed a few slides ago, if you add additional node, let's say you have 3 nodes, maybe you need another or 2 more, you just say to which cluster you're adding, and then it will know in the background, okay, I had 3, now I have 5 or 4. Now what do I do? And then all these actions, previously you would need to do by yourself. In AWS, it's going to redistribute for you. So there is a pretty good blog post if you just type AWS ElastiCache Q&A. There are probably about 100 questions what's going to happen, and probably this scenario, it will show, you can find probably that same question, how they actually perform that.
Okay. I have another
Sure,
question.
sure.
About
Go ahead.
okay.
Yeah.
About the SQL part. So you said we can create a table and then we can query it with
Yeah.
SQL. But can we query something we haven't created as a table? Or do we need to create it as a table so we can query it?
At the beginning, you will need to create it as a table, and not only that, if you're planning to use Redis SQL, when Redis SQL is starting, you need to start with additional module.
Oh, I see.
So, for example, regularly you would start Redis with Redis server, press enter, and it starts. If you want SQL, you would say Redis SQL -- import and that specific library. So then Redis will know to load that library. You cannot load after you start it.
Yes.
You need to stop it and then restart with that additional library. Then when it started, then you need to create the table first,
Yeah.
and then you can insert data and retrieve.
Okay, but there is no way for me to retrieve the data that I haven't created as a table first.
Correct.
There's just no.
No, because it's completely different data type. For example, by default, you have a hash or set or
Yeah.
other default data types, but this is none of those.
Yeah.
So it's completely different. So because it's different, you cannot really create from nothing. So only when you start it, then it's not, okay, I have a different data type, which is SQLite implemented in memory. It's almost like if you ever run SQLite in your, without Redis, just regular, and then you say, instead of file, you're using a memory. This is how they implement it here. So they use memory, and the Redis is just server who is just a layer for SQLite. It doesn't do anything specific. It's just kind of, here's the Redis, here's on top of it SQLite, and that's it.
Okay, I understand.
Yeah. Any more question? We have 1 more minute. Sure.
Hi. I suppose the slide that you showed the time it takes to store keys scaling nicely linearly. Is that dependent on the object size as well?
Little bit, but I would say a little bit on object size, but more on how many transactions or how many hits you have per second. In this case, I think I ran all the way up to 1 second with many keys. If you add the keys, it would degrade a little bit. If you add the size of the key, let's say from few kilobytes to few megabytes, it will start degrading. Yeah. But and then you need to start thinking how big the value is. It's always kind of a mix of what technology support and then what you really need to do with your application. Sometimes you may not need all the data to store inside the Redis. Sometimes you need maybe 30% of data and the rest you can keep somewhere else. So yes, it will degrade, but then you can start. What I usually do is I kind of run this experiment and then see where my limit is. And then maybe I talk to whoever is running user experience and say, okay, what time limit we need to hit and how much data we need and how big is the cluster. So based on all these factors, you can see, okay, if I want to run under 300 milliseconds, I need maybe 5 node clusters because I have 5 read replicas, so I can quickly read. Or write. So that's another question, is like, is your application write heavy or is read heavy? You know, because sometimes it's easier when it's only read, because you can replicate everything and then maybe 100,000 users go to first node, another 100,000 to the second node, so it's easy. Maybe slightly harder with a write. But anyway, you can run these experiments and see the size of the key, how many per second on average you have, and then you kind of can gauge in size the cluster fine-tune, yeah.
Thanks.
Sure. Thank you.